sky notes. You might see that the sky notes contain a lot of pictures of M101, which I'm sure there's a good reason for that. So yes, could we just have the lights down a bit, please? Because there's kind of lots of night sky pictures in here, and it's good to be dark. That's kind of better. Yeah, that's much better. Okay, so sky notes. So we're in the middle of the summer. I think you all know that. And in the summer, we expect to have nice sunny weather, and most of us have. But those of us who are unfortunate and live on the east coast of our island have been suffering really persistent cloud, and I've been finding it incredibly frustrating. I'm in Chelmsford, which is kind of down here somewhere, and people sort of having clear skies and lovely sunshine, and I've just been under this persistent cloud for weeks and weeks and weeks. And it's been very, very, very frustrating when I've seen what other people have had to deal with. But at least when it is clear, it does get dark-ish where I live. Last September, for the Elgin meeting, Peter Carson and I went up to Dennis's up in Scotland, and we installed a little camera which looks north from his observatory. And as you can see, he's got an absolutely wonderful northern horizon. So this camera picks up aurorae and other things during the year, but at the moment, it also shows just how incredibly bright the sky is where he lives. He lives 58 degrees north. And actually our Deep Sky Station director, Callum Potts, has recently beaten that. He's moved up to Orkney, and I think he's about 59 degrees north. So anyway, here we are. The time on here is in UT. So this is about 9 p.m. UT, which is 10 o'clock at night. The sun is just setting. And then the next picture is at midnight. And we're not even at midsummer yet, but this is basically Dennis's northern horizon at midnight. It's very pretty, it's lovely. You can actually see this star here, of course, which is Capella, which is the star that we see in a lot of noctilucent cloud pictures at this time of the year. But yes, it's a kind of demonstration, if we need it, that the Earth has a 23.5 degree tilt in its axis, and if you happen to live far north, even if you've got clear skies at this time of year, it's not really possible to do much in the way of astronomy. So no comet pictures from Dennis at the moment. Some lovely stuff being posted on the members page. I particularly like this one. So this is actually a set of images taken by Pat Devine, although in fact wasn't taken by Pat Devine, it was taken by a Raspberry Pi, which is programmed to wake up every morning just before sunrise and take pictures of the sunrise. And again, another really good demonstration of the fact that not only does the sun, well, the sun effectively moves north declination in the summer and south declination in the winter, and of course that means that the sun moves along the horizon at the point where it rises. So at this time of the year, the sun is rising as close to north as it gets, and setting about as close to north as it gets. And this is a really nice sequence of that happening sunrise over Edinburgh Castle. Again, Edinburgh not quite so far north, but the effect still very impressive. So, okay, if you live up that far north, what can you observe? Obviously the sun. And the sun's actually been quite active recently. Lots of really impressive images being submitted to the association. This was the sun this morning from a spacecraft. I think this is it Solo NDI, or one of the spacecraft images anyway. A few nice active areas there on the sun. It's actually been more active than this. But Simon Dawes has submitted some very nice images of sunspots. So here's one. You get really good impression here of the solar granulation, these small convection cells in the sun's photosphere, but also in the amazing structure that you get within sunspots. And here's another one by Simon showing that group, that larger group there. So sun's definitely worth observing at the moment if you've got the right equipment to observe it. And of course, hopefully, if you're not under the cloud that we have in the east of England, it's actually available in the sky fairly frequently. Steve Knight submitted this one, and me doing my geeks thing, I think thinks that's an A320, Airbus A320, or maybe a 319. But this is of course the sun with something flying in front of it, and it's one of the The perils of observing from the south of England is that you get a lot of aircraft flying around, and if you're observing the sun at a particular time of day, you get these things going across. But there you go. So in addition to the nice sunspots there, you've got an aircraft flying over as well. This one I particularly like. This is from Alan Halsey, and this is a hydrogen alpha picture of the sun, but it's taken in a way that's not the normal way that we see these days. Most hydrogen alpha images of the sun are taken using narrowband filters. This is taken using a spectroheliograph, which is effectively a spectroscope, which you can tune to any particular wavelength you like. And you then scan the spectroscope line across the image, across the focal plane to produce an image. And if you do that fast enough, you can actually see it visually, but you can image it. And the nice thing about these kind of instruments is that you can actually tune it to any wavelength you like. So you don't need to buy a whole set of different filters. You can tune your spectroscope to what you want to look at the time. It's obviously a much more complicated way of observing the sun, but it shows really nice high contrast there of all sorts of features on the sun's surface. So, mentioning the sun, every now and again we've got a useful occulting disk that orbits the Earth that just happens to be the same size of the sun and moves in front of it. That's the moon, of course. And Jeremy said about the ability to predict the path of eclipses. We can do that incredibly accurately. And in fact, my future holidays until the point I can't travel anymore are pretty much determined by eclipses. This is the one that occurred last April, or the April just passed. It was a really interesting eclipse, this one, because it was only just total. So the moon was only just close enough to the Earth to cover the sun, and then only near along the central part of the track. At either end, where the moon the Earth curves downwards, the moon was too far away, and so it was an annular eclipse at the beginning, annular eclipse at the end, and a total eclipse in the middle. And as you can see from the track, it doesn't really cross much in the way of land, but it does conveniently cross a little tiny peninsula in northwest Australia, here, near a town called Exmouth, and luckily there is also a Royal Australian Air Force base there, which serves as an airport. And so it was possible to actually go to Perth and then fly up to see the eclipse. Now I was lucky in that I flew up a couple of days beforehand, and I could settle in, and on eclipse day I could get up and have my breakfast, wander over, set up my telescope, and whatever. But there was a much more complicated trip which they gave to their key troubleshooter on eclipse trips, which was basically getting something like 200 people up from Perth on the morning of the eclipse. Flew them up, put them on a bus, get them to the eclipse site, see the eclipse, brought them back. And of course that was John who dealt with that side of things, because if anything goes wrong, you want John to be there to sort it out. But amazingly, it worked.
Brilliantly.
Now, the local people in Exmouth knew that something significant was happening. So this was in the town the night before I went in. They actually had all sorts of things. But yes, indeed, a major event was in progress. And that event was this. This was the total eclipse that we saw. Where we were, it was really short. It was about 56 seconds long. But it was really gorgeous. Because the moon was so close in size to the sun, we actually got to see prominences all around the disk. We got to see the chromosphere as well. This is a video I shot using a Sony A7S camera on the back of a Megrez refractor. You can see that really big prominence there sticking out from the sun. That was gorgeous, really nicely visible in binoculars, but there were other prominences as well. And the corona was magnificent. It was this beautiful symmetrical corona, which is the kind of corona you expect to see coming up to solar maximum. So, yeah, the eclipse was very short, but it was really quality, this one, rather than quantity. And I really enjoyed it. The wide-angle shots here were taken with a GoPro camera, so that gives a kind of good impression of the site we were at. And you can see there a bit more detail in the corona as we go through the eclipse. And then only 56 seconds after it started, it ended with a really impressive diamond ring, which is just about to come up. Now you can see, there it is.
Oh, wow. Yeah.
So that was a really nice eclipse. And what was really interesting was to compare the prominences that we saw at that eclipse, which were about 0300 UT, to images taken in the UK in hydrogen alpha that following day. And you can see this Carl Bower picture on the right, my eclipse picture on the left. Really nice correlation between the prominences we saw like 10 hours earlier. And that big prominence there, Carl submitted this extraordinary image of it. So we were just so lucky that this prominence was there at the time of the eclipse, because it was a really, it's probably one of the most prominent prominences I've seen at a total eclipse. It was very, very impressive. So there are a couple of other solar eclipses coming up, both cover the US. There's one in October, but that one's only an annular eclipse, so that's not really worth making too much effort to go to. I mean, if you happen to be anywhere nearby, it's worth looking at, but you don't actually see very much in terms of anything other than kind of the moon going in front of the sun. But Jeremy's already mentioned this one, of course, the really big one, which is, it says May there. That's not good. Don't go on May the 8th, go on April the 8th. This is my sneaky way of trying to avoid too many people booking hotels. But yeah, it crosses Mexico and Texas and then goes up into the US on April the 8th, not May the 8th. I'm not responsible for any errors in this presentation. Anyway, okay, on to other stuff. So another thing that we get at this time of year is some really nice displays in the sky. I was really taken by this image from David Swan, taken on an iPhone, and in fact more and more stuff seems to be taken on iPhones. They are remarkably good these days at taking sky pictures. But this shows all sorts of lovely arcs, circumzenithal arcs, various other arcs, sundogs, all in the ice crystals in cloud. And these are not only just beautiful, but they're a really interesting demonstration of physics as well, physics and optics. And you know, if you want to encourage people to kind of understand a little bit about how optics works, explaining to them why you get these halos, these 22.5-degree halos and the other things is a really good way of doing that. That was ice crystals in tropospheric cloud, so fairly low down. Of course, we're now entering the time of year when noctilucent clouds are visible. But they've been rather slow to start this year, and there haven't been many images from the UK. There have been some images taken from Denmark and Scandinavia generally of NLCs, but we haven't had any certain ones from the UK yet. This is a picture, stretched picture taken from a camera that I've got poking out an upstairs bedroom window that just records continually looking to the north. And we think this is probably NLCs. You can see the structure there, which is quite different from the structure you get in tropospheric cirrus cloud. But it's very, very, very faint. But the thing to do is, this time of the year, looking out, look to the north, look for NLCs. We've got kind of like 6 weeks now going into the NLC season when these things should kick off. Now, normally, as solar activity is increasing, which it is for us at the moment, NLC activity decreases. But there's been some significant volcanic activity over the last couple of years, and that might enhance it. So definitely worth looking out. If you've got clear skies, look to the north around midnight, kind of later than midnight, and see if you can see these silvery clouds, which are high up in the mesosphere, far higher than any terrestrial clouds, so they get illuminated by the sun long before terrestrial clouds get illuminated. So they're usually fairly easy to distinguish from clouds lower down, normal tropospheric clouds. So the moon, it's kind of just gone through a full moon, which was called, I think, the Strawberry Moon. I saw somewhere. I just hate these names, but the Strawberry Moon. But you might have noticed when the moon was full last that it was very low down, and that's because we're approaching a thing where the tilt of the moon's orbit lines up with effectively the tilt of the ecliptic. So the moon ends up going very, very far south and very, very far north. So it can either be very high in the sky or very low in the sky. I think it's next year when it reaches one of these extremes, when it's something like 28.5 degrees southern declination. So it's the moon at the moment, when it's full in the summer, is always low, but it's particularly low now compared to what it was several years ago. This rather nice picture of the crescent moon by our president, showing lots of nice features, and of course trying to get the crescent moon shortly after new moon is always a good fun thing to do. Also low down, also in the twilight, we have recently had quite a nice conjunction, which was the moon here, and then just below it Mars, and then Venus. This rather nice picture from Andrew Patterson shows that. And of course Venus is a planet that's very, very difficult to miss in the twilight at the moment, extremely bright. It's just been through what's called dichotomy, which is the point where the phase of Venus is exactly half. So that's at the point where it's at its greatest elongation. It should have an exactly half phase. These pictures taken in various different wave bands show that in particular in the UV, you can actually see quite impressive details on Venus. And this is one of the things which I find quite remarkable now, is that amateur images of Venus used to be very bland, but now amateurs are imaging in the UV. They're picking up really impressive atmospheric cloud structures. So this shows that very, very clearly, but we've also got examples here from Peter Tickner showing these images basically showing lots and lots of detail in the planet. Okay, this is upside down for a reason, as you might notice. So most planetary observers seem to present their images with south at the top, whereas some don't. They put north at the top. But I turned this upside down on purpose in order to make it line up with the other images I'm showing. So this is to demonstrate this effect of dichotomy. So there's this anomaly that has been reported for many years, that at true dichotomy, when Venus is at its greatest elongation, when it should look exactly a half, it doesn't. It appears to look less than a half. It's called the Terminator anomaly. I think most people now agree that it is either a visual effect or an image processing effect, because essentially Venus's clouds, if you imagine near the terminator, the sun is very low down, so the brightness of the terminator falls off a lot towards the actual sunset point. And so depending on how you process your image or how you look at Venus through a telescope, you don't register that darker part. And this year, various people, Pete Lawrence and others, have processed images to show that actually on June the 4th, when theoretical dichotomy was due, Venus really did look a half phase. So this Terminator anomaly is really a perceptual thing rather than a real thing. But it's interesting to observe, and Paul Abel has done some rather nice drawings, as always, of Venus going through dichotomy, showing this effect quite nicely. We don't have many other planets around at the moment. They're either off behind the sun or they're very low down. If you're in Australia, you'll be lucky enough to see some rather nice views of Saturn at the moment. And Saturn is showing, as it moves around the sun, the orientation of the rings changes depending on our viewing angle. And the rings are closing up now. So you can actually see a lot more of the surface of Saturn because it's not hidden behind the rings. And these rather nice images from Trevor Barry, again, show quite a lot of detail given the current position of Saturn. But the really big news comes from this guy. So this guy is Kiichi Itagaki. He's been discovering things for a very, very long time, sort of 40, 50 years or so. But he has just recently discovered a supernova in the Pinwheel galaxy, M101, which is perfectly positioned for us at the moment in the UK. It's almost at the zenith. So here it is. This is a lovely image from Mazen Yunis showing the supernova popping on and off here. So this is an image taken after the supernova had been discovered, compared with an image taken a couple of years ago, or a year or so ago. And you can see the supernova is really, really prominent in the arm of the galaxy there. Images of this galaxy tend to make you think, well, it must be really easy to see this galaxy. It's got a total magnitude of, I think, about magnitude 8, so it's quite bright. But essentially all of that light is spread over a really large area on the sky. So imaging it is relatively straightforward. But seeing the galaxy visually, even in quite a large telescope, is really hard. However, the supernova is a point-like object. And so the supernova is about 11th magnitude, 3 magnitudes fainter than the galaxy, but it's a star-like object rather than the galaxy. So the supernova is much, much easier to see. I mean, even me, a non-visual observer, I've looked through a telescope and the supernova is visible. I couldn't see the galaxy, but I could see the supernova. And this is from Chelmsford, where the skies aren't particularly good for deep sky. Just rattle through a few more images. Peter Tickness here, before and after image. This really nice one from Ian Sharp, who lives on the south coast, actually not far from Selsey, and it's been one of those lucky ones who's had clear night after clear night, whilst I've been looking up at my sky, cursing the clouds off the North Sea. Andy Wilson got in on the act and did an actual drawing. That's pretty good. So, you know, it is worth looking at this thing visually, because you're seeing something, you know, you're seeing a supernova with your own eyes, which is pretty impressive to do. And it's quite a bright one. We don't often get supernovae this bright. People have been measuring its magnitude, and here's its light curve. What's really interesting is that this thing was detected after the discovery by people looking at their images. It was detected something like getting on for a day before it was discovered. So a really bright supernova was sitting in a very common galaxy for almost a day without somebody discovering it. So that must tell you something about the kind of probability of discovering supernovae now. I was really surprised about that, because I thought, you know, these galaxies were patrolled to death. So the fact that it was there for so long before it was discovered.
We haven't got Ron.
Yeah, well, indeed. Just think, well, no, the trouble is, Ron, what would have happened with Ron is that his telescope would have broken on the night. I was actually really impressed to see that the guy who bought Ron's telescope, the 17-inch and the camera, actually took an image of this supernova, which is really nice, I think, that Ron Arbor's telescope was actually used to image this. It's on the BAA observers. So taking spectra of it as well. So this is with a star analyzer, so fairly low resolution spectrum. But there it is. This was actually taken when the supernova had effectively become a fairly bland object spectroscopically. And this shows this quite nicely. This is a time series of spectra taken by Robin Ledbetter, showing that initially the supernova had quite strong emission lines for a very short period of time, and they all then faded away as the blue end of the spectrum faded as well. And so what you're seeing here towards the end is essentially a black body, the fireball of the supernova, radiating as a cooling black body. So the blue end going away more than the red end. And I just think this is fascinating. I mean, it's amazing stuff done by an amateur. Admittedly, Robin is you know, about the best amateur there is doing this, but it's pretty amazing seeing this in this time lapse. So I better rattle on. You've already kind of started to give away something, but this is our Corona Borealis. So not T Corona Borealis, but our Corona Borealis. And this star has been kind of sitting around at about, 6 magnitude, just under, for quite a while. But there are some indications that it might have started to fade. And this is the latest AAVSO light curve. You can see this fade happening here. So this is definitely a star worth keeping your eye on. So if you're going to be watching T Corona Borealis, just move a little bit across to the centre of the crown and have a look at R at the same time. Another one that's interesting around at the moment is one of the novae, V1405 CAS, and it's got quite an interesting light curve, had quite a lot of humps when it went off. It's now sort of settled down a bit. But Mike Harlow, using an objective prism this time, again, has taken some low-resolution spectra, and you can see the difference between the nova, which has got all of these emission lines, and most of the stars, which are dominated by continuum. So these, they may be quite low resolution, but I find these fascinating, these objective prism or the star analyzer images, because they just show you the nova compared to the other things in the field. Right, this is something that I'm particularly keen on. So this is the launch of the JUICE spacecraft on its way to Jupiter. It won't get there until 2031 because it's got a long route. It has to do lots of swing-bys. Launched on the last Ariane 5 because by now Ariane 6 should have come along to replace it, but it hasn't, so it's been delayed. So ESA have had to put lots of stuff on other rockets. In fact, there's an ESA launch coming up. It's going to be on Elon Musk's Falcon 9 next month. But this is the launch of JUICE, an amazing spacecraft that's going to go on its way to Jupiter. You may have seen that there were some problems deploying one of the big radar antennas on JUICE, but after a lot of shaking and firing a couple of mechanical devices, they actually got this thing to deploy. This thing on the right there is one of the ground station dishes that is used to communicate with the spacecraft. It's a 35-meter diameter paraboloid antenna, which weighs something like 600 tons. And I was lucky when I was down in Perth for the eclipse to go out and visit this. This is at a place called New Norcia, about 100 and some odd K outside of Perth. And that's what's used as the receiving antenna and the commanding antenna for this spacecraft. It's going to produce some really spectacular images of the Jovian system. But what I particularly like about the camera's called Janus. So Janus is an acronym, but it's not an acronym in English, it's Latin. So I know you're classically trained. I'd be interested to know, Jovis is obviously Jupiter, Amorum is loved, I guess. If you actually put that into Google Translate, you get the most rubbish translation you can possibly imagine. And in fact, somebody on the Planetary Society used that, and it translated Jovis as Thursday. And it's just rubbish. But I think it means basically the camera that's going to love looking at Jupiter's family, sort of, something like that. But I'd be interested if any classical Latin scholars have got a better translation. But there you go, an instrument on the spacecraft, very posh, with an acronym that's Latin. I like that. We get John Cleese out to help us translate it.
Boris translate. Yeah, Boris translate.
Well, he could do that, yeah. He hasn't got anything else to do. Anyway, as the spacecraft was heading away from the Earth, some of our observers managed to image it. So this is a really nice Grant Privet image when it was about 800,000 K away. You've got the spacecraft on the left there, and the upper stage cryogenic booster on the right. Nigel Evans did it amazingly when it was something like 7 million kilometers away. And it's remarkably bright for a spacecraft that far away, but probably because it's got very big solar panels and the angle of the solar panels was just right to make it bright. So it was about 18th magnitude at 7 million kilometers. This is one of the furthest away images of a man-made object that I'm aware of, and it was taken in Ipswich.
That's fantastic.
Okay, so we're kind of coming up to sort of the summer break, but after the summer, of course, we have the Perseid meteors. In fact, our next meeting's not going to be until, I think, September sometime. So remember to look out for the Perseids this year. The maximum of the Perseid meteors, August the 12th, corresponds to almost perfect conditions. The moon is very close to new. and assuming we get clear skies, we should get a really nice view of the Perseids, and there's one of them from my meteor camera. So as John was talking about earlier, meteor observing has changed quite a lot. Very few people doing visual meteor observing now, but for something like the Perseids, it's still worth getting out and just actually, seeing what meteors look like. It's always good fun. And if you can arrange to do it with other people, that makes it even more fun. So just finally, comets. There's not much going on in the comet world at the moment, but this one, which is always worth looking at, 29P Schwarzmann-Bachmann, has now gone into conjunction, so we won't see it again until the autumn. But the light curve here that has been compiled by Richard Miles for us in the section shows just what an active object this is. And the other interesting thing about this object this year is that we now know its orbit much better than we used to know it, and we know the positions of stars much better than we used to know it. So it's possible to predict occultations of this object, which is about 60 kilometres wide. And there was a prediction of an occultation that crossed over the UK on May the 7th. Unfortunately, very, very low. I think it was about 12 or 13 degrees above the horizon when this occurred. But Malcolm Jennings in London managed to get a very short interruption in the light curve. You can see it here on the left, which we think is a grazing occultation of this comet. And it's an amazing thing that we're able to predict occultations with this level of precision of small objects further away than Jupiter, and then observe them. Amateurs can observe these and do really, really important science. There were quite a few misses. My one is this trail here. The actual path shifted quite a long way west, and the weather wasn't very cooperative to the west, unfortunately, so observers who were in the ideal place didn't actually get a chance to observe it. But this is an amazing achievement. We now have our first comet occultation observed from the UK, positive comet occultation. In terms of comets that are around at the moment, there isn't a whole lot around. This one, which one is this? 127? No, 287.
Linear.
237. 237P. This is one of Peter's images. So this is the kind of comet that's around at the moment, fairly indistinct. But there is one that's actually brightening up quite nicely, and it's this one, 2023 E1 Atlas. It's brightening up quite rapidly, and we think it should reach maybe 9th magnitude or so in a month's time. Again, a bit like M101 though, it's an extended object, and so even though 9th magnitude sounds quite bright, the comet itself is relatively faint. But it's definitely worth, if you've got right equipment, definitely worth going after it. It's well positioned. It's basically passing through Ursa Minor, so again, it's high up in the sky. You can actually get it on quite small instruments. I photographed it with a 72mm refractor, just as a small green fuzz. So if you want to have a challenge over the summer of photographing a comet, have a go at this one, 2023 E1. Then finally, just a plug before you all go home about this lovely place. This is the view from Flamsteed House at Greenwich, looking down over the amazing view over Greenwich Park. And then this is what you see coming back. And the reason I'm showing these lovely pictures is to encourage you to book up to go to the Comet Section meeting, which is on Saturday, July the 8th. It's at the National Maritime Museum in this wonderful lecture theatre. We're getting it through the kind offices of the National Maritime Museum and Flamsteed Astronomy Society. We're getting it for free, which is a fantastic deal for us. To reciprocate, I want to make sure that it's a really well-attended meeting. We've got some excellent speakers, including Professor Alan Fitzsimmons, who's going to be talking to us about exocomets. So comets that have come from elsewhere and gone into our solar system and then gone back the other way. So if you're interested in coming, all you need to do, go on the website, go and register for the meeting. There's still quite a few places left, but I imagine that as we get closer, those places will get used up. I know some people are waiting to see whether there'll be a train strike that weekend. But once the RMT have announced the dates, hopefully it won't be that weekend, the places will get filled up fairly quickly, I think. So I'd love to see you at the comment section meeting. Got some great speakers. It's a fantastic venue. We're going to get a planetarium show from the planetarium on site as well whilst we're there, related to comets. John will be talking about comets and meteors, and a really good stellar lineup of speakers. So thank you very much. Enjoy your summer. Hopefully you will be in that part of the country that has clear skies, not under the North Sea cloud. Look out for NLCs. Just look out for all the kind of atmospheric phenomena we have at this time of the year. And of course, have a look at that supernova whilst it's still bright. Because it'll fade away, and you'll have missed the opportunity if you don't. So thank you very much.
Thank you very much, Nick.